All right, today we're going to deal with exponential functions. You guys have dealt with this in Algebra 2 to some extent. We're going to add a couple more things to it. So an exponential function looks like this, where this base is any number larger than 0. No, I'm sorry. Larger than 0 and not equal to 1. So any number that's larger than 0 but not equal to 1, so we would say B follows the rule, B belongs to the set of, we're going to go whole numbers, and we're going to say B does not equal 1. So that's what we're talking about here. We have two options. We can have exponential growth, and we can have exponential decay. I know I'm off the screen. Give me a second. Growth is when B is larger than 1, and decay is when B is less than 1. But remember, it still has to be greater than 0. So what that means is growth is if I have like if I have like 4, it's going to be exponentially growing. It's going to be going like this. If I have like 1/4, it's going to be exponentially decaying. It's going to be going like this. So that's what we're looking at here, okay? We're going to do a couple of things with this. The first thing that we're going to do is I'm going to give you a base function. I'm going to say, here's your base function. If I do this to the function, how is it changed? So if I do that, we know that there's certain things that move it up, down, left, right, vertically compressed, stretch, horizontally compressed, stretch, stuff like that. So we're going to follow the same rules that we did before. We're going to say A is in the front, and then this number, I'm going to put B again. Am I going to put B? This is going to be a little bit confusing. The B is like the 3, okay? And then it's going to be to the power of 1 over, I'm putting little b. That's the b that we did before that does my horizontal stuff. X minus h, and then plus k. So remember, A, if it's absolute value of A is greater than 1, it's a vertical stretch. Absolute value of A is less than 1, it's a vertical compression. If A is a negative, it's reflected across the x-axis. B, if the absolute value of B is greater than 1, and remember it's 1 over B, so this would look like 1/2 and B would be 2, then it's horizontally stretched. Absolute value of B is less than 1, it's horizontally compressed. If B is a negative, it's going to be reflected across the y-axis. Remember that H is going to move me to the left and right, and K is going to move me up and down. I don't think you guys have too much trouble with this. We're going to do a whole bunch of examples in class, but let me just give you one. So using that same base function, 3 to the x, if I have something like this, I'm going to look at it. This is A. It's absolute value larger than 1, so it's going to be vertically stretched by a factor of 4. This 9 is going to move me to the right 9, and this 2 is going to move me up 2. So you guys are pretty good at that. We won't worry about that too much. The other thing that we're going to do with these is we're going to do something where we have compounding interest. And we're going to have two different equations for compounding interest. This is like if you get a credit card. So a lot of you guys say, like, can't we see where we would actually use this in life? Well, a lot of us are going to have credit cards in life, so this is an opportunity for us to do that, okay? So the final amount that we have or that we owe is going to be equal to the principal or the starting amount, how much I started with, times 1, plus if I'm getting more, minus if I'm getting less, the rate, which is the percentage as a decimal, over the number of compounding terms, times the number of, to the power of the number of compounding terms times time. So if I say I'm giving you a credit card, you borrow $100, you have 25% interest per month, and how much are you gonna owe at the end of 5 years? So what we're gonna do here, our starting amount is that $100. So we're gonna say the final amount is equal to $100, 1 plus, because we're gonna owe more money. The rate, which is 0.25, remember I have to put it as a decimal. The number of compounding periods, well, it compounded every month, so that's 12 months in a year, to the power of 12 times the number of cycles, which is 5. So I'm going to do this on my calculator real fast. Hopefully this calculator works. And it tells me at the end of 2 years, I owe $344.58. Whenever I'm dealing with money, I'm gonna round to the nearest penny. Then we have another formula when we compound continuously, which is how most things actually work. If you get a home loan or something like that, it actually compounds continuously. So that, the final amount, is going to be equal to the principal times E, which is Euler's constant. This is a number, Euler's constant, to the power of the rate as a decimal times time. So if I did that same thing, I got $100, but it compound continuously at 0.25 times 5. Whoa, was it at the 5 years? Yeah, 5 years. 5 years. I'm gonna put that in my calculator, and I'm gonna owe just a little bit more when it goes this way. I'm gonna owe, when it goes this way, $349.03. So most banks, when they when you owe money, they're gonna compound continuously. So we'll do a little bit more with these when we come to class.